structure. So whatever needs to be done, basically. These are my handles. 1 minute, it's my name, and the time rule WTH, which is my surname. And these are the cards that we were, printing in the Bogota. Probably know about it, about the story, how successful it was. There was over 2,000 people in the queue, so we were just working a full day to just print those cards for the people. These are the NFC cards, basically keeps all your information and retrieves all the information from your ENS and whatever you have on your ENS name. So these are actually your web-shape profile. And this was the first implementation of something physical. So the people were sharing their information, their contact through these cards. So when you tap to that card, the NFT just shares this information with the phone or the device that you are using. And so today we're going to talk about what is ENS super shortly. What's actually the main topic is the CCI period today, so I'm going to tell about what is the CCI period, what does it do, and what are the key components of CCI period, and what are the use cases for it. So first of all, the ENS Ethereum name service. Who is familiar with ENS? Alright, so for who doesn't, I will just quickly tell about it. So ENS is an open protocol on top of Ethereum, but not for the Ethereum. So basically to help people to resolve the alphanumeric characters easily, or not instead of remembering the alphanumeric characters like your wallet addresses or any machine identifiers, you are using ENS to be able to resolve or find those information. So basically, let's say you create a wallet and you have a public address and you want to receive an amount of token, and then when you want to share this with your friends, there's always this problem of checking if everything is correct. So you know how it works. It's always a really stressful time that what if one letter is changed, or what if someone just hacked your computer and when the copy paste needs to change. So instead of doing this check, we're just basically bringing a super nice UX to the blockchain world. So what we do is we are resolving those addresses for you. You have your handle, and everything is on chain, and basically decentralized. And today's topic is the CCI period, basically the cross-chain interoperability protocol. READ stands for Secure Data Retrieval. So what does it mean? What it does? CCI period is crafted by the founder of ENS, Nick Johnson, and the reason for that, and what does it do? Why we created that? Why it became a specification? Let's start with that. So the problem started with this. ENS is keeping all the information in a vault. And in the beginning, everything was super easy because the gas prices were low, and the user was able to use the register the ENS, to keep the records under the ENS super easily, because we didn't think that the gas price is going to go that crazy. But it happened after a lot of use cases just landed into Ethereum. So at that moment, we were like, okay, everything was fine, but now we need to find look for the other options. And before we started to see the development of the L2s, like many the side chains and L2s just try to scale the Ethereum, so try to solve this problem of like high gas cost or the availability or the scalability. And naturally, we are working on top of Ethereum. We wanted to scale too. And the problem is none of the solutions on that time was working for us. So we start to write down what are our problems, and how we can solve this issue. So the first problem was how we can store the ENS data on L2 without clients having to know how to query every L2, which means we have some client implementations like Ether.js, Web3.js, or other Rust implementations, other language implementations. And so we don't want to have a specific implementation for each L2 implementation that we want to do. Instead, we were trying to find a way that we're going to create some solution that's going to work for every L2s out there, or even not only L2s but also the off-chain or some other solutions, basically. So we were trying to generalize it. And the other concern was without any additional trust assumptions. What that means, so while creating a solution for our problem, we shouldn't introduce any more trust assumptions, so people shouldn't be worried about, like if it's signed by some third parties, or if it's shared with someone else, if it's centralized, or this kind of things. And the third concern was without any L1 commits on update. So basically, we want to create a solution to retrieve some information from L2, but at the same time, we don't want to touch anything on L1 level. So we don't want to force users to sign the things, do the transaction, or like whenever they query something, we don't want to create additional transactions or things. We don't want to complicate things. And the other concern was without any transactional query. I already explained this actually, it's a part of the L1 commit. So we didn't want anyone, while querying their names on the L2s, we didn't want anyone to be involved in more transactions or the steps, basically. And without hard requirements on the L2's capabilities, which means that while scaling to other L2s, we didn't want to do any modification on the current L2s. So we don't want to introduce any other complexity while scaling. And after thinking all these problems and all these concerns, first we checked the current implementations or the current approaches. And the first thing comes to mind is basically the token version. So you know how it works. Basically, if you have a token in L1 and if you want to just use the L2, you can lock some amount of token and you mint the token in the L2. And you are sending a message that you did the log means for you use the L2, and vice versa. Well, it was a nice beginning to think about, like, okay, maybe this can help us. It didn't, because we are not using the tokens for managing the ENS records. What we do is basically we are keeping the records without using any token standards. We are doing a lot of reads, unlike the other protocols or other projects. So instead of people are writing into like a DeFi, etc., we just read the state. Most of the time, we are just reading the state from the changes. And then on that side, like after that, we thought that okay, this is not going to work for us. But let's deep dive into primitives. So what is the primitive of the token release? The message passing. We said, okay, we are not doing anything with the tokens. Let's get rid of this and just use the message passing. Because if you know the message passing is basically just, it's a way to communicate between the L1 and L2. So basically you are telling, like, if you are using the L2, L2 tells the L1 that, like, if something happens on your site, please prove me so I can proceed further. If somebody locked the token, please tell me that it happened so I can just proceed further. I can mint the token. Or if someone burned the token, I can unlock the token in the L1. Okay, so we are going somewhere that we can really use this mechanism. Then, after starting investigating the message message passing, we realized that, okay, without doing much modifications, we cannot really use the message passing as well. So it was one of our requirements for the console. Then we start to deep dive into the message passing as well, like what's message passing using as a more primitive way, like what kind of things it does. Maybe we can find something from that. And the most primitive part of the message passing basically is the proofs, the storage proofs, state proofs. And basically when you are just checking for the L2 or checking for the L1, the L1 or the L2 has to prove something happening there. And okay, like this may work for us because we also in ENS we also need to prove that like something is happening in one side, and then when we get this information, maybe we can like find a proof that like this whatever happens there can be proved by us. I know it's getting complicated, but yeah. So we were like, okay, let's think about this, the proofs. Then after that, I will just go back to the problem. So now, we were saying that like without nice having to know how to query every L2, and we realized that this primitive of state proofs are universal for all L2s because they have to work with the L1. So it is a must for them to implement this primitive. And we can use it for our benefits. It means that the client doesn't really have to know which L2 we are interacting with because we are using this primitive and all of these L2s have it by default. And without any additional trust assumptions, again, like the token bridges are using this message passing primitive is this. So we basically there is already trustless way of checking the storage proofs. So we are not introducing any additional trust assumptions. Without any L1 commits, we are not doing anything in that sense too, because it's just approving whatever is there in L2 or L1. And same for the others. We are not changing anything in L2 capabilities because we are just using whatever is there. And we came up with a solution which called CCI Build. And this is the most basic way of showing how the CCI Build works. I will try to explain it. So we have three actors. One of them is client. So again, as I mentioned, it can be any kind of clients like EthersGS, WAGMI, EthersRS. And we have a contract. So the contract can be any contract basically based on your use cases. And in our use cases, it's a resolver. And we have gateway. So this is the actor that we introduced into the system instead of using the massive passive. Because we said, okay, like we have to prove something and there's a primitive for that. Why not creating a trustless gateway to do that for us? So if we don't have to keep any state on L1, we don't have to keep any state on L2. We can just use the gateway and retrieve this information from any L2 and do the proof and then send it to the L1 contract back and check the verification if everything is fine, which means that the data is available in L2. So how does it work? Maybe let me explain a couple of things here first. So, as a user, there is no difference when you are using this specification. So basically, it's just like doing a transaction. As a client, you are calling some contract function. It goes to contract, and in the traditional way, if the contract has the information or the blockchain has the state, the information, it will just read and retrieve the data for you. Or if it's not, it will just revert and it will say that it's not found. But in our case, what we did is we used the new feature of the Solidity features after Solidity 6, I guess, which is custom errors. It's not really new, but it's kind of And what we did is, so we are asking contract for some function. We are saying that, oh, we are looking for some data. And the contract checks and it says that, no, I don't have it, but I know where it is. And instead of reverting a not found error, it reverts a custom error which is called off-chain lookup or off-chain data error. And this error has all the information for where the data is, basically. And we have the sender information, like who is checking for that. This is for the security reason, so I'm just skipping that. We have the URLs. URLs are basically the gateways. So which gateways can retrieve this data for you. And we have the callback function. The callback function is, okay, it means that like, you go to gateway, you ask for the data, you retrieve the proof of the data as well, and then use this callback function to verify if everything is correct. Then I will tell you that, okay, this data is definitely correct. And the extra data is just for the callback function. There are some extra data based on the use cases. You can just pass any data. It can be like something arbitrary, again, based on your use cases. And then the clients get this error and then do a HTTP request to the gateway with all this information. And the gateway retrieves the data from wherever it needs to retrieve. It can be off-chain or it can be from L2. And we get the response, but the response is opaque, so we don't understand what is inside it. There is some result, there is some proof, but it needs to be verified if it's the real result, basically. So we are using the callback function, and it goes back to the contract. Now we have the proof, we have the extra data to verify that proof, and the contract just do the verification and sends the answer. So we didn't write anything into the blockchain just because of that it's gas-free. We retrieve the information from outside, like I don't know, like it can be just, any database or it can be outside. Again, based on the use case. So from here, it's hard to think about use cases, like what can be use case for, how does it work. So let's maybe go with something concrete. I don't know if you ever used ENS in a development level. So like if you try to resolve something, if you try to retrieve some information from your resolver, like for example your address or your avatar information. But it's pretty much like that. You are asking for the resolver address of the name. You get the resolver contract. You ask the resolver that I want this specific information for this name, like for example, avatar for this name. And it retrieves this text for you, and you have the URL. And in the off-chain case, or in the CCIP read case, things are changing a little bit. So, this is you. Now, you want to resolve some information. Let's say you want to resolve address of a name. And this is the address I want to resolve. Sargo.ebs, etc. And in the regular resolver, if there is no information or there is no address for this name, it would just say, no, I don't have it. That was the regular resolver behavior. But with off-chain resolver, things are changed. It's not saying no. It says, I don't know what this address, I have no idea, I don't have any record for this name, but there might be a place that you may want to look for. So this is what we call off-chain lookup error. And we are sending the relevant information. It says that like, please go to this gateway URL, and this was your call. And ask the same call to that gateway, so it can check for you if it's available. And then if somehow the gateway is able to find the information, please go back to this function with that result, and this function will help you to just verify if everything is correct. And the extra data is basically based on our use cases. We have a couple of external verification measures. Then, by the way, these all things are happening with using, let's say, byte or letters. Now we have information. We go to the gateway. Gateway checks with all this call data if there's anything in the connected, let's say, storage. So this storage can be off-chain, so it can be just a regular database. It doesn't have to be L2. That's the beauty of having the CCRP, by the way. You don't have to retrieve information from the L2. You can use anything. So you can have a database, you can just use some external API to retrieve information, so it can behave just like an Oracle. Or you can just use any, again, like the on-chain integration with the others. So we are asking Gateway if you have this information, and the Gateway says, yeah, I have this. Here is the information, and here is the proof. And please, you already know the, like what you're going to call for the verification. This is a callback function. And then the client does send the proof to the callback function. This is all the callback we call here. And then after the proof check, if it's verified, it's true, the contract sends the information to the client back, and the client sends the information to the user. Now we have information without touching anything or without writing anything to them. And while talking about the gateway part, I mentioned about two things, the off-chain interaction and the on-chain interaction. So there are some use cases that you may just want to use some basic database instead of using L2s. Like, let's say in your company you just want to give away free subnames, but you really didn't want to use writing the states into L2. You just want to use your own database, just keep everything there, because it's your company. You don't really care about the decentralization of that time. You just want to give a free names because you have some idea. That's it. So the pros of off-chain is that it's like no gas. So you are not interacting with blockchain at all. So you can just have simple Web2 style registration. You can even manually register people into your database, and when they query for their name, it will retrieve all this information, and they will be able to use their names as a, like a regular investment. Even in the MetaMask or like any other wallets, when they write their names, it will retrieve this information from your database. So of course, there's a little trust assumption here is if you are not able to do a verification mechanism, there is only one verification mechanism works for the off-chain interaction. It is basically you have to keep some trusted key pair. So whenever the query happening to the off-chain interaction, to the off-chain gateway, these messages should be signed by the trusted key pair that you give to the gateway. And then the resolver is able to verify that the messages comes from the trusted part, because you are giving the public key to the resolver before while creating your contract. And so another problem of the off-chain interaction is that the data may not be publicly available, of course, because it's just a database. So the company or the project may just choose to have some private database, just keeping like all the names there. So it's again like it's kind of quick solution for basically creating nice ideas. And for the on-chain interaction, if you decided to go full decentralized version of this, if you just choose to have a handle for your users, but not like L1 gas prices with the super cheap option, you can just use the L2. The thing is, it's not free. It's like as the off-chain result, the off-chain gateway. But you don't have any additional trust assumption because the L2 already has it built. And this, I'm not going to explain all, but it's more or less what we already talked about when we talked about like how we are retrieving the information from L2. Why I put that? It's from Vitalik's blog and his take about how we can use the CCIP read to scale units. So if you see, it's actually more or less the same what I described previously. So basically, there is an actor asks to CCIP contract if the data is available, and the CCIP contract returns the off-chain lookup error, and then it goes to the gateway. Gateways fetch the Merkle proof to see if the data is there and available, and if it's the real information. And then we call the callback function. The checking the state what's happening here, and then we retrieve back in actual results to the user. And he explains in more detail and like how we can benefit this exactly in ENS and also the other protocols. So I would definitely suggest you to check if you are interested. And our end goal is not being in one L2. Basically, we want to be L2 agnostic. So if there is any L2 there, like user shouldn't be forced to just use one L2, like let's say ENS on Polygon or ENS on Hybrid. So the user should be able to choose freely if they want to, if you want to scale ENS, they should be able to freely move their information between these from L1 to L2, L2 to L2. So this is ultimately, and we want to sync up like all the names, so there won't be any the clashes and the problems in between. And in the wild, there are already some uses of the CCIP read that you see. Not all of them here. Like for example, Arden was using the old way of creating subnames. Basically, they were just giving the subnames to everyone in L1. And after the gas prices get high, they had to stop because it was costing them a fortune. And for the lens, so basically every lens name is an ENS name because they are also using this this specification. So we are able to retrieve the lens name as an ENS name. And the most obvious one is the Coinbase. So if you ever use the Coinbase wallet, when you get onboarded, the Coinbase asks you like if you want to get a handle, and you're going to get it for free. So what they do is they have cv.id, which is a DNS name, and they are using one other spec that we created for the DNS names, which is DNSSEC groups. So they are using their regular domain name as an DNS name, and then they are using the CCIP to issue handles for the people for free. But what they do, they are not using any L2 states, L2 blockchain, they are using their own database at this moment. But at some point, they want to move all the names to their own chain. And yeah, if you are interested in the CCIP read, and if you think that there is a use case in your protocol, in your project, please let me know. So I'm available for any questions. I'll just engage more actively.
Any questions for